Discover magazine article titled "This Star Went Supernova and Then Went Supernova Again" by Jake Parks, dated November 9, 2017. To quote the first line of a letter published today in the journal Nature, every supernova so far observed has been considered to be the terminal explosion of a star. In other words, when a massive star blows itself up, it should remain dead. This is something astronomers have witnessed thousands of times before with absolutely no exceptions. That is, until now. For the first time, astronomers have discovered a star that has gone supernova more than once. This so-called zombie star, which exploded at least twice in the last 60 years alone, has baffled scientists by challenging many of the existing theories about how massive stars end their lives. This supernova breaks everything we thought we knew about how they work, said the study's lead author, Iyer Arkavi, a NASA Einstein postdoctoral fellow at the University of California, Santa Barbara, and Los Cumbres Observatory, in a press release. The undying star, named IPTF 14HLS, was first discovered in September 2014 by the Palomar Transient Factory, a fully automated wide-field survey designed to spot cosmic objects that vary in brightness over time, such as variable stars, transient objects, and of course, supernovae. Although supernova IPTF 14HLS initially faded after its 2014 explosion, within a few months, it began to mysteriously grow brighter again. Over the course of 3 years, IPTF 14HLS fluctuated between bright and dim at least 5 separate times. When the astronomers realized IPTF 14HLS was not an average supernova, they decided to go back and search through archival data. The researchers were flabbergasted when they found that in 1954, another explosion was recorded in the exact same location as IPTF 14HLS. Somehow, the star survived its first explosion, waited 60 years, and then exploded again, 5 separate times more. The first thing that came to my mind when I read this article was the Star of Bethlehem. The Gospel of Matthew talked about a mysterious star that appeared, disappeared, and then reappeared again a second time within a span of 2 years or less. Matthew chapter 2 verses 1 to 16. After Jesus was born in Bethlehem in Judea, during the time of King Herod, Magi from the east came to Jerusalem and asked, "Where is the one who has been born King of the Jews? We saw his star when it rose and have come to worship him." Then Herod called the Magi secretly and found out from them the exact time the star had appeared. He sent them to Bethlehem and said, "Go and search carefully for the child." After they had heard the king, they went on their way, and the star they had seen when it rose went ahead of them until it stopped over the place where the child was. When they saw the star, they were overjoyed, and having been warned in a dream not to go back to Herod, they returned to their country by another route. When Herod realized that he had been outwitted by the Magi, he was furious, and he gave orders to kill all the boys in Bethlehem and its vicinity who were 2 years old and under, in accordance with the time he had learned from the Magi. Thus, a supernova similar in nature with IPTF 14 HLS and capable of exploding multiple times over a period of several years can explain the Star of Bethlehem in the same manner the Gospel of Matthew described it. The only question in my mind was how to identify which supernova among a list of over 10,000 observed supernovae was the Star of Bethlehem. Now, a star in the sky can be uniquely identified by its coordinates in the equatorial coordinate system, which is a celestial coordinate system widely used to specify the positions of celestial objects. It is a system defined by an origin at the center of Earth, a fundamental plane consisting of the projection of Earth's equator onto the celestial sphere, forming the celestial equator, a primary direction towards the vernal equinox, and a right-handed convention. The fundamental plane with the primary direction fixed towards the vernal equinox means that the coordinate system, while aligned with Earth's equator and pole, does not rotate with the Earth, but remains relatively fixed against the background stars. However, since the primary direction is fixed towards the vernal equinox, and since the position of the vernal equinox changes slowly over time due to precession of the equinoxes, this means that the star's celestial coordinates also change over time at the same rate as Earth's precession, a circuit which, by the way, completes in about 26,000 years. Now, if we are talking about a supernova explosion that occurred just a few years ago, this slow precession of the equinoxes can be ignored. However, if we are talking about a supernova explosion that occurred more than 2,000 years ago, this gradual precession has to be taken into account. And this is why, to correctly identify the supernova, which was also the Star of Bethlehem at the time of Christ's birth, it is important to know first when exactly Christ was born. In my previous video titled, When Was Christ Born and When Was He Baptized? The year, month, and day revealed at last, I concluded that according to the Julian calendar, Christ was born after sundown on Friday, January 9, 1 BC, and before sunrise on Saturday, January 10, 1 BC. Using the Gregorian calendar instead, Christ's birth is dated after sundown on Friday, January 7, 1 BC, and before sunrise on Saturday, January 8, 1 BC. And as I mentioned in my previous video, Orthodox Christians in Central and Eastern Europe and other parts of the world do celebrate the Old Christmas Day or Christ's birth on January 7. Now, knowing the exact date of Christ's birth is not enough to correctly identify the Star of Bethlehem. We also need to know the exact location of where Christ was born and where he was first seen by the Magi from the east. This is because, in astronomy, there are two angle measurements that locate a point on the celestial sphere in the equatorial coordinate system, the first being declination, symbolized by the Greek letter delta, the other being the right ascension, symbolized by the Greek letter alpha. Declination's angle is measured north or south of the celestial equator, and since the celestial equator is aligned with Earth's equator, its value in astronomy is comparable and equivalent in angular value to geographic latitude on Earth projected onto the celestial sphere. And this means that for an observer on Earth, the only star which this observer can see directly overhead in the sky at the observer's position for a given moment in time, which is also known as the zenith, will be the star which crosses the observer's meridian at that moment in time and whose celestial declination has the same angular value as the observer's geographic latitude. This is because for a star to be directly overhead an observer's position, the star's transit altitude must be exactly 90 degrees, and a star's transit altitude is calculated as 90 degrees minus the observer's geographic latitude plus the star's celestial declination, and this calculated value can only be 90 degrees if, as mentioned earlier, the observer's geographic latitude equals the star's celestial declination. In one of my previous videos titled Absalom or Sorek Cave, the true location of Christ's birthplace and nativity, I mentioned that by knowing the geographic latitude of Christ's birthplace, one can also identify the Star of Bethlehem. This is because, according to Matthew's Gospel, the star stopped over the place where the child was, and this meant that the star's celestial declination was equal to the geographic latitude of Christ's birthplace. Since Absalom or Sorek Cave is located at 31 degrees 45 minutes 21 seconds north, this means that the celestial declination of the Star of Bethlehem should also have the same value or very near it during the time of Christ's birth. Now, knowing the year, month, and day of Christ's birth is still not enough to uniquely identify the Star of Bethlehem or the supernova associated with it. One has to know the exact time during the day when Christ was born. And fortunately for us, a total lunar eclipse visible in Israel occurred on the very night Christ was born on January 10, 1 BC, according to the Julian calendar. And I believe Christ was born at precisely the exact moment when this total lunar eclipse was at its greatest eclipse. Since according to Matthew, the Star of Bethlehem stopped over the place where the Magi first saw the baby Jesus, astronomically speaking, this means the Star of Bethlehem was at the zenith of the sky or directly overhead where baby Jesus was seen. And thus, the constellation where the supernova or the Star of Bethlehem belongs to must have also been at the zenith of the sky at that time as well. If we now use the Stellarium software, we can see that at the time of greatest eclipse, which was also the moment when the moon's elongation was at its maximum on January 10, 1 BC, the constellation Leo was at the zenith of the sky in the Sorek Cave where I believe Christ was born. And knowing this immensely helps us to narrow down our search for the Star of Bethlehem to one of the supernovae, specifically and only in the Leo constellation. Locating the Star of Bethlehem in the Leo constellation should not be a surprise. After all, the town of Bethlehem where Christ was born belonged to the tribe of Judah, and this tribe is without a shadow of a doubt represented by the constellation Leo. And this is based on how Jacob described Judah as a lion and also on how the book of Revelation described Christ as the lion of the tribe of Judah as well. Genesis chapter 49 verse 9. Judah is a lion's whelp. From the prey, my son, thou art gone up. He stooped down, he couched as a lion, and as an old lion, who shall rouse him up? Revelation chapter 5 verse 5. And one of the elders said unto me, Weep not, behold, the Lion of the tribe of Judah, the root of David, has prevailed to open the book and to loose the 7 seals thereof. Now, by using the comprehensive list of stars in the Leo constellation, we can see that the right ascension of the stars of the Leo constellation ranges from a minimum of 9 hours, 23 minutes, 31.85 seconds to a maximum of 11 hours, 55 minutes, 40.53 seconds, while the declination ranges from a minimum of minus 5 degrees, 4 minutes, 46 seconds to a maximum of 32 degrees, 23 minutes, 4.6 seconds. But since the geographic latitude of Christ's birthplace at the Sorek Cave was 31 degrees 45 minutes and 21 seconds north, I further narrowed down my search for the stars in the Leo constellation to those stars whose declination at the time of Christ's birth was very near this value. However, because of precession of the equinoxes, which I discussed earlier, the current declination of the stars in the Leo constellation, which I am searching for, should now be between 21 degrees to 25 degrees only. With this in mind, I now use the comprehensive list of all supernovae reported since 1885 to identify all the supernovae in the Leo constellation. And I was specifically looking for those supernovae whose current right ascension ranges from a minimum of 9 hours, 23 minutes, 31.85 seconds to a maximum of 11 hours, 55 minutes, 40.53 seconds, and whose current declination ranges from a minimum of 21 degrees to a maximum of 25 degrees only. And this is how I discovered that the supernova SN 2009 NW, located at the Leo constellation, was in fact the Star of Bethlehem. SN 2009 NW is a Type 2N supernova, abbreviated as SN2N, and this type of supernova has very interesting characteristics. According to the website Cosmos, the Swinburne Astronomy Online, some Type 2N supernovae behave like a hybrid supernova, possessing both characteristics of a Type 1A supernova, abbreviated as SN1A, and a Type 2 supernova, abbreviated as SN2. This website cited the case of supernova SN 2002 IC in particular. SN 2002 IC was classified as an SN1A, but over the following weeks, and much to the surprise of astronomers, the spectrum of SN 2002 IC evolved into that of an SN2N. In other words, if we had not observed SN 2002 IC at earlier times, we would have classified it as an SN2N and not an SN1A. If SN2N do arise from both SN1A and core collapse supernovae or SN2, this will explain why only some SN2N are radio emitters while others are not. Type 1A supernovae are the result of the explosion of a white dwarf in a binary system as it goes over the Chandrasekhar limit, either due to accretion from a donor or mergers. The Chandrasekhar limit is the maximum mass of a stable white dwarf star. Consequently, a white dwarf with a mass greater than this limit is subject to further gravitational collapse, resulting to a supernova explosion and then evolving into a different type of stellar remnant, such as a neutron star or black hole. A Type 2 supernova results from the rapid core collapse and violent explosion of a massive star. A star must have at least 8 times, but no more than 40 to 50 times the mass of the Sun to undergo this type of explosion. Unlike SN1A, where nothing remains after the explosion, SN2 tend to form supernova remnants of ejected stellar material. For a Type 2N supernova or SN2N to exhibit both SN1A and SN2 characteristics, one of the binary stars should have at least 8 times but no more than 40 to 50 times the mass of the Sun to undergo a Type 2 supernova explosion. Afterwards, the white dwarf star forming this binary should accrete the remnants of ejected stellar material resulting from the Type 2 supernova explosion of the more massive partner star. These remnants of ejected stellar material should be massive enough to cause the white dwarf star to reach the Chandrasekhar limit thus resulting to another supernova explosion, and this time of type 1a. And this will explain why SN 2009 NW, a type 2n supernova, and which I believe to be the Star of Bethlehem, was seen brightening twice by the Magi from the east at a span of 2 years or less. Now, when was the first time the Magi saw the Star of Bethlehem explode and brighten up? Approximately 2 years before the birth of Christ, according to the Gospel of Matthew. The supernova explosion of a star is an unpredictable event, and it was unlikely that the Magi were observing the sky with the hope of seeing one by chance. So what very important astronomical event instead were the Magi actually observing that time? www.universetoday.com Venus and Jupiter's upcoming conjunction by Fraser Cain. A conjunction very much like the one occurring on the 5th of November 2004 occurred in August 12 of the year 3 BC. That year, Venus and Jupiter were only 10 arc-minutes or 0.16 degrees apart in the constellation of Leo the Lion. With such a narrow separation, light reflected from the two would seem to merge into one as seen with the unaided eye. Some scholars have speculated that this close conjunction may have been interpreted as a sign by a group known as the Magi. The Magi, or wise men, were priests of an ancient religion known as Zoroastrianism. Could this close conjunction have been what sent the wise men traveling to a far-off city known as Bethlehem? The Magi from the east were observing this very rare Venus-Jupiter conjunction when all of a sudden and quite unexpectedly, supernova SN 2009 NW, which I believe to be the Star of Bethlehem, exploded and brightened many times in magnitude right before their eyes. And since both the Venus-Jupiter conjunction and supernova SN 2009 NW were located in the same constellation Leo, these astronomical events were observed by the Magi simultaneously. But wait, there is more. The very rare Venus-Jupiter conjunction on August 12, 3 BC also coincided with the annual heliacal rising of Regulus, the brightest object in the constellation of Leo and one of the brightest stars in the night sky. The traditional name Regulus is Latin for prince or little king, and the heliacal rising of Regulus on this day, coinciding with the close Venus-Jupiter conjunction and the surprise supernova explosion of the Star of Bethlehem, were probably the reasons why the Magi from the east interpreted these astronomical events as the birth of a future king. Allow me to explain this conclusion a little further. Matthew Robinson, in his work titled Ardua et Astra, on the calculation of the dates of the rising and setting of stars, and which was published by the University of Chicago Press, dated the annual apparent morning rising, abbreviated AMR, of Regulus every August 12, starting from 100 BC until sometime before 401 AD, when this annual date changed to August 14 due to precession of the equinoxes. Robinson defined apparent morning rising, also known as heliacal rising, or first visibility, as when the star crosses the eastern horizon shortly before the sun, and is thus briefly visible for the first time. With every morning that follows, the interval between the star's rising and sunrise increases. The star is visible earlier and for longer. This heliacal rising is the first of many visible risings. Thus, the heliacal rising of a star, being the first of many visible risings, After a period of invisibility due to its close proximity with the sun, which outshines the star with its surpassing brightness, can be considered as the annual reappearance or rebirth of a star. Now, while the heliacal rising of a star is the first of many visible risings of the star, the apparent evening rising, abbreviated as AER, also known as the visible acronical rising, is, according to Matthew Robinson, the last of these many visible risings of the star. The star crosses the eastern horizon just after sunset. On previous days, the star had crossed the horizon sometime after sunset, and so its rising was easily visible. On subsequent days, the interval between sunset and the star's rising diminishes, and the sky is too bright for the star's rising to be seen. And by the time the sky is dark, the star is already some distance above the eastern horizon. Thus, the apparent evening rising is the last visible rising of the star after sunset. And according to Matthew Robinson's calculations, this annual acronical rising of Regulus was every January 9 of the year, starting from 100 BC until sometime before 401 AD, when this annual date changed to January 12 due to precession of the equinoxes. Now remember, in my previous video titled, When Was Christ Born and When Was He Baptized? The year, month, and day revealed at last, I concluded that Christ was born after sundown on Friday, January 9, 1 BC, and before sunrise on Saturday, January 10, 1 BC. Thus, the first time the Magi from the east saw the Star of Bethlehem was on the day of the year 3 BC of Regulus' annual first visible rising, namely August 12, and the second time the Magi from the east saw the Star of Bethlehem was on the day of the year 1 BC of Regulus' annual last visible rising, namely January 9. Thus, the two times the Magi from the east saw the Star of Bethlehem in a period of more than a year, but under 2 years, coincided with the first as well as the last visible rising of the star Regulus. Now, if you will notice, SN 2009 NW was in very close proximity with Regulus and was having an altitude almost the same as that of Regulus, and therefore their angular distance with the Sun was also approximately the same. Thus, for SN 2009 NW, or the Star of Bethlehem, to be visible in the sky during the heliacal and acronical rising of Regulus, the Star of Bethlehem should be equally bright or brighter in magnitude as Regulus. And if the brightness of the Star of Bethlehem was indeed equally bright or just slightly brighter as that of Regulus, then it can also be said that the heliacal and acronical rising of the Star of Bethlehem must have coincided with that of Regulus. And this, I believe, was what the Magi from the east meant when they said they saw his star in the east, or according to some translations, at its rising, referring to the heliacal rising of the Star of Bethlehem the first time they saw it. Matthew chapter 2, verses 1 to 2, New Revised Standard Version. In the time of King Herod, after Jesus was born in Bethlehem of Judea, wise men from the east came to Jerusalem asking, "Where is the child who has been born King of the Jews? For we observed his star at its rising, and have come to pay him homage." This theory, which interprets the phrase in Matthew chapter 2 verse 2 at its rising as an astronomical term concerning a heliacal rising, was also proposed by Edersheim and Heinrich Voigt, among others. But wait, there is more. I also believe that the Star of Bethlehem exploded a third time during Christ's baptism, which in my previous video titled, When Was Christ Born and When Was He Baptized? The year, month, and day revealed at last, I concluded happened on November 24, 29 AD, during a total solar eclipse visible in Israel. During this event, one can see that at the time Venus and Mercury became temporarily visible due to the darkening of the day sky caused by the solar eclipse. Supernova SN 2009 NW was positioned in the western sky and was about to set. If the Star of Bethlehem exploded once again during Christ's baptism and brightened to a magnitude close to, if not brighter, than Mercury or Venus, then during the solar eclipse, John the Baptist would have seen in the darkened day sky not just Venus and Mercury, but also the Star of Bethlehem as well. And I believe this is why the Gospel of Matthew described this event as heaven opening and revealing the stars that were hidden by the sun's glare. Matthew chapter 3, verses 16 to 17. As soon as Jesus was baptized, he went up out of the water. At that moment, heaven was opened, and he saw the Spirit of God descending like a dove and alighting on him. And a voice from heaven said, This is my Son, whom I love. With him I am well pleased. Now one may ask, if supernova SN 2009 NW exploded 3 times from the period starting from August 12, 3 BC until November 24, 29 AD, then why weren't any records, independent of the Gospels, made of these explosions by the astronomers of that time? If you still recall, SN 2009 NW, which is of type 2N supernova, behaves like a hybrid supernova, possessing both characteristics of a type 1A supernova and a type 2 supernova. And according to the curious.astro.cornell.edu website, in their article titled, How Long Does the Supernova Stage of a Star Last?, we get the following information. Type 2 supernovae, which are thought to be the result of core collapse of a massive star, generally have a plateau in brightness before dimming more slowly. Their peak brightness can last several months, while type 1A supernovae, which are believed to result from matter falling onto a white dwarf in a binary system, are typically brighter but fall off more quickly, with a peak brightness lasting only a few hours to days. I believe supernova SN 2009 NW, which was initially a binary star system, first exploded as a type 2 supernova when its massive star had a core collapse, leaving behind remnants of ejected stellar material. These ejected stellar material were then accreted by its companion white dwarf in the binary star system over several periods of time, 3 times to be exact, according to my reckoning. And each time the accreted stellar material caused the white dwarf to exceed the Chandrasekhar limit, the white dwarf exploded to a type 1A explosion with its peak brightness lasting only a few hours. Thus, only when an astronomer happened by chance to be observing the sky when this short and momentary brightening of the supernova occurred, Can astronomical records be made of these events? And unfortunately, only the gospel writers or their correspondents were fortunate enough to witness these events and write about them. Also, as I mentioned earlier, I believe the brightness of the Star of Bethlehem was just slightly above that of Regulus, and as such, it would appear as a regular star in the sky to many people, and only a trained astronomer would have known that it was actually a new star shining in the constellation Leo. Now, having said all that, let me now discuss in detail the brightening or supernova explosion of SN 2009 NW, or the Star of Bethlehem, at the time of Christ's birth. I believe Christ was born at the exact moment when the total lunar eclipse of January 10, 1 BC was at its maximum. And using the Stellarium software, this should also be when the moon's elongation or the angular separation between the sun and the moon was at its maximum. The time of greatest total lunar eclipse at the Sorek Cave, where I believe Christ was born, occurred when the sun's hour angle was 12 hours, 23 minutes, 28.65 seconds, which means it was 23 minutes, 28.65 seconds past midnight, local Bethlehem time, when Christ was born. The time when the Star of Bethlehem, or supernova SN 2009 NW, was at its zenith was when the hour angle of the Star of Bethlehem was exactly 0 hour, 0 minute, and 0 second. And this happened at exactly 1 hour, 27 minutes, 58.92 seconds past midnight, local Bethlehem time, when the hour angle of the sun was 13 hours, 27 minutes, 58.92 seconds. And this time was also 1 hour, 4 minutes, 30.27 seconds after Christ was born. During this interval of time between Christ's birth and the rise of the Star of Bethlehem at its zenith, the Star of Bethlehem was still rising from the east and traveling to the west, and was still being followed by the Magi from the east. Matthew's Gospel tells us that the Magi from the east saw the baby Jesus inside a house at exactly the same time when the Star of Bethlehem, having an altitude of 90 degrees, stopped over the place where the child was. Note that at 90 degrees altitude, the star was neither rising nor setting in the sky, and thus it would appear to temporarily stop over the house where it reached its zenith. And for this to happen, the geographical latitude position of this house must have exactly the same angular value as the declination of the Star of Bethlehem, and which was 31 degrees 47 minutes 25.4 seconds north at that time. Now, in comparison, the Sorek Cave where Christ was born has a geographic latitude position of 31 degrees 45 minutes 21 seconds north only. And this tells me that after Christ was born inside the Sorek Cave, Christ and his family must have moved to a house that is located 2 minutes 4.4 seconds due north of the cave. If we now look at Google Earth, we can see that there is actually a village currently named Beit Meir at this location. And the house where I believe Christ and his family moved to immediately after his birth must have been located at the southernmost tip of this village, where the latitude position was 31 degrees, 47 minutes, 25.4 seconds north, or exactly the same as the declination of the Star of Bethlehem that time. In addition, the southernmost tip of Beit Meir is located approximately 3.34 kilometers north of the Sorek River. And in my previous video titled The Star of Bethlehem and the True Location of Christ's Nativity at Avshalom or Sorek Cave, I mentioned that the town of Ramah, which belonged to the tribe of Benjamin, and the town of Bethlehem, which belonged to the tribe of Judah, were adjacent to and in close proximity with each other, and that these two towns were separated by the Sorek River, which served as a border between the two territories. Now, since the territory of Benjamin was located north of the territory of Judah, it is quite clear that Beit Meir, which is located north of the Sorek River, must have been the town called Ramah at the time of Christ's birth. And because Christ and his family moved to the town of Ramah right after his birth inside the Sorek cave located in Bethlehem, this explains perfectly well why the soldiers of Herod the Great also slayed all the male child 2 years old and under in the town of Ramah, and not just in the town of Bethlehem. Matthew chapter 2, verses 16 to 18. When Herod realized that he had been outwitted by the Magi, he was furious, and he gave orders to kill all the boys in Bethlehem and its vicinity who were 2 years old and under, in accordance with the time he had learned from the Magi. Then what was said through the prophet Jeremiah was fulfilled. A voice is heard in Ramah, weeping and great mourning, Rachel weeping for her children and refusing to be comforted, because they are no more. The Gospel of Luke tells us that immediately after Christ was born, an angel of the Lord announced his birth to shepherds living out in the fields nearby the place Christ was born. Luke chapter 2, verses 8 to 12. And there were shepherds living out in the fields nearby, keeping watch over their flocks at night. An angel of the Lord appeared to them, and the glory of the Lord shone around them, and they were terrified. But the angel said to them, "Do not be afraid. I bring you good news that will cause great joy for all the people. Today, in the town of David, a Savior has been born to you. He is the Messiah, the Lord. This will be a sign to you. You will find a baby wrapped in cloths and lying in a manger." In my previous video titled The Star of Bethlehem and the True Location of Christ's Nativity at Avshalom or Sorek Cave, I mentioned how the temperature and the humidity inside the Sorek Cave where Christ was born are constant year-round. And for this reason, I believe the shepherds who visited the baby Jesus in the Sorek Cave must have enfolded their flock in another nearby cave as well, where their sheep were protected from the cold temperature of winter. And indeed, there was another cave named Meyarat Shimshon, or the Shimshon Cave, located approximately just 1.61 kilometers northeast of the Sorek Cave. The Shimshon Cave is located north of the Sorek River as well, which means that this cave must have belonged to the town of Ramah. And this explains perfectly well why Christ and his family moved to a house in Ramah immediately after his birth, since the shepherds who visited him were residents of Ramah who must have invited Christ's family into their home after seeing the baby's miserable condition in a manger inside a cave full of animals. After traveling approximately 1.61 kilometers from the Shimshon cave to the Sorek cave, the shepherds, this time together with Christ's family, traveled approximately 4 kilometers from the Sorek cave to Christ's temporary shelter house located at the southernmost tip of Beit Meir, also formerly known as Ramah. Thus, the shepherds traveled a total distance of 5.61 kilometers from the time the angel of the Lord announced Christ's birth to them until they provided a temporary shelter in the town of Ramah to Christ and his family. Now the question is, how much time did the shepherds take to travel a total distance of approximately 5.61 kilometers? Specific studies have found pedestrian walking speeds at crosswalks ranging from 5.32 kilometers per hour to 5.43 kilometers per hour for younger individuals. Using 5.32 kilometers per hour as the average speed with which the shepherds and Christ's family walk continuously, the time they will need to travel a total distance of 5.61 kilometers would have been around 1 hour, 3 minutes. And if you still recall, I mentioned earlier that the time when the Star of Bethlehem or supernova SN 2009 NW was at its zenith was exactly 1 hour, 4 minutes, 30.27 seconds after Christ was born. And it was exactly at this moment when the Magi from the east also saw the baby Jesus in the shepherd's house in Ramah. Thus, the shepherds and Christ's family had just recently settled on this shelter house in Ramah when the Magi from the east also arrived barely 1 minute later, if not exactly at the same time. And this perfect timing of independent events and perfect positioning of scattered places relevant to the birth of Christ can only be possible if SN 2009 NW was indeed the Star of Bethlehem.